This is going to be a walkthrough of the Causality exporting GUI. So to start it, we can run the M file, and here is the GUI as of September 1st. So the new feature is, or from the previous version, is the ability to use multiple subjects and cluster sources and view region to region connectivity across a group of subjects. But for now, we'll overview the entire GUI itself. So to start off, we want to load it. If we're looking at single subject causality or connectivity, we load a EEG file into EEG Lab, and this file has been ICA'd and cleaned to whatever preferences you want. And first, we're going to enter the source numbers, or the ICA components that we are interested in looking at connectivity between. And next, we're going to enter the window size. So this is in number of samples, and this number will basically vary depending on your data length or what time range you want to analyze over. Here I have a file of 100,000 samples at a sampling rate of 256 Hertz. So depending on the win size here, it'll affect the time ranges that I'm able to use. And so once I enter this window size, I can click Update Time Ranges, and the time ranges that get divided from my total samples appear here. And here I can select which time ranges I want to use. I can select a single one, or I can select multiple ones by Control left click. But for now, I'll just select 39 to 78 seconds. And lastly, I'll select the frequency ranges I want to use. So here, there's no limit to the number of frequency ranges you want. You can just enter them as a list of this format. So it goes start of frequency range 1, end frequency range 1, start of frequency range 2, end of frequency range 2, and so on. So just start end separated by spaces. And lastly, if I want to export visual or visualizations of the connectivity calculations, I can select this button here. So we'll have head plots of the connectivity in addition to an Excel spreadsheet showing the connectivity, and I'll show you both of those right now. So after that, we'll just hit run, and the causality will calculate. So depending on your file size, it might take a couple minutes to do this, but for the purpose of this video, I'll just cancel and then show you the outputs that would come out of it. So for connectivity, this is what will come out. So I have my sources I've selected here, 1, 3, 5, and 9. I have the net sum causality between these two sources. So this is, for example, 0.0024. So that would be the net sum of causality between 1 and 5, and combining that with the causality between 5 and 1. And depending on whether that's positive or negative, the direction of the arrow will represent which source has a greater causality on the other source. And lastly, for color schemes here in visualization, I will be changing it so that, for example, source 1 here is green, but the arrow coming from it is red. It will be changed so that the sources that these arrows are coming from will be the same color, so it's just easier to visualize. So for example, the connection between 1 and 9 will be green, the connection between 3 and 9 will be blue since it's originating from 3, and so on. So just for easier visualization, that's something I'll add. And lastly, these files will be saved into the directory where your EEG file originated from, and they'll be saved as a date and the current date and time. And looking at the file here, and inside the file name we'll have GC head plot, we'll have the frequency range, we'll have the time range, and we'll also have the EEG file name so you can keep track of what file they are. And next, if we want to look at multiple subjects, so with multiple subjects, you can see that instead of using specific sources, I'm going to be using clusters, which I will calculate. And we'll go through how to calculate that. But first, I want to load an XLS batch file. And if I find the batch file, so the batch file will look like something like this. So we have basically all the folders and all of the EEG file names just as a list here. And after that, so you'll make that file, you'll click the load XLS batch file button, we'll find the batch file and hit open. So it'll place the batch file into here, and then we can click view and choose clusters. And what this will do, we'll look at the sources from all of the EEG files. It'll go through them, it'll find the XYZ coordinates of all of the sources contained in those files, and it'll combine them all together into a matrix. And it will use k-means clustering with different k-values as shown here, and we'll go through that, to basically find groups of sources which are nearby each other. So we can go through that and see what that actually means. So for here, I'm looking at k-values from 2 through 8, so they're represented in the titles of the figures here. And for example, in k equals 2, it'll try and best divide the set of sources into 2 clusters which are separated from each other. So here is basically separated left and right hemisphere. As we go on through more and more clusters, it will separate them more and more. So we have 5 clusters here, 6 clusters here, and the clusters will be different colors, and you'll keep track of which clusters you're interested in by these numbers and color representations below. So based on which areas you want to observe connectivity from or calculate it from, you can select your k-value to see how specific you want your region to be, and second is how many sources you want inside that cluster. So for now, let's look at k equals 6. So I have already calculated this. So since I'm not interested in these other k values, I can just close these figures, or I can save them if I wanted. And let's say I wanted k equals 6. So I'll go back to the GUI and I'll say, okay, k value is 6. And now we want to see which clusters we want to look at connectivity from. So I've already calculated from frontal to occipital causality. So here, blue is my occipital sources, and that's cluster 1, and frontal is 5, so I'll just say 1 and 5. And now, for my window sizes, I want to calculate this again. So since your files may be of different lengths, or data lengths or time lengths, you want to calculate this again, and it will go through all the files and find the time ranges which are consistent across all your files. So it'll basically use the shortest EEG file as your time limitations. Alright. And lastly, we select the frequency ranges as normal, and we can select the Save Head Plots button as normal, and we can click Run again. And again, I've already run this, so I'm just going to look at what the output looks like. So remember, I was looking at frontal to occipital connections here, so this is what comes out of it. So I have basically all the connections between sources that are contained inside these clusters. So for each subject, there are specific sources which have been classified into this cluster, and I'm essentially overlaying those connections here to see an overall frontal occipital connectivity on the group level. And we have the 3 views here, and we have the color scheme I had mentioned before, where the connections originating from, for example, the frontal sources here are the light blue, and originating from the dark blue occipital sources are the dark blue arrows here. And the output will look similar to what we saw before. So we have the EEG file names, we have the sources that correspond to cluster 1, we have the sources that correspond to cluster 2, and we have the connections between the sources represented here. So from source 1 to source 2 is this value, source 2 to source 1 is that value, and if I were to basically subtract these, I would end up with the numbers that I see here. And we have these for each of the EEG files. And lastly, something I forgot to mention is for the single subject connectivity, we also have graph theory measures calculated on the connectivity here. So looking at single subject, I have some sort of network of connectivity with different magnitudes between different sources or regions, and the graph theory measures represent how well connected either certain subnetworks or the overall network is. And these are flexible, and what I mean by that is they are used from a separate toolbox, the Brain Connectivity Toolbox. So if there are certain measures that we want to use from there, they can easily be added and calculated from these networks and added into this Excel spreadsheet. But what I have here is basically just a set of graph theory measures that correspond to this specific network, and I have the image file that corresponds to these graph theory measures. And that's it. Alright, thank you.